Hello everyone. This video is about the tutorial that I have given on microwave engineering in the LMS. So let's go to that microwave tutorial. So you can go to the announcement section, and here you can find the tutorial. You can download it, and so let's try to attempt the questions in the microwave tutorial. So the first question is about a plane wave traveling along the x-axis in a region with epsilon r equals 2.8 and has electric field given by Ey equals E naught cos omega t minus kx. And the frequency is 5 gigahertz, and the magnitude of the electric field is 3 volts per meter. So we are asked to find the following: the amplitude and the direction of the magnetic field, the wave velocity, and the wavelength. So first, let's actually understand that this is a question about uniform plane waves. So in our lecture, we have learned that how we have learned about uniform plane waves and how to find the direction of the electric and magnetic fields based on the Fleming's right-hand rule. So once we have the information that we have information about the one of the two of the components, we can find the direction of the other component. So we have been given a situation where the wave is traveling in the x-axis, and the wave is in the x-axis, and the other thing is that the electric field is in the y-axis. So the wave is propagated along the x-axis. The electric field is following along the y-axis, and it is given as E naught cos omega t minus kx. So x here means that the wave is propagating along the x-axis. So using Fleming's right-hand rule, we can see that the magnetic field should be in the perpendicular direction to both x-axis and y-axis, which should be z-axis. So the magnetic field we can denote as HZ is in the x-axis. So in this question we have been given some data. So it's better if we can note down the data that is there. The wave is traveling, and it is traveling in a certain medium which has epsilon r equals 2.8, and the frequency of the wave traveling is 5 gigahertz. And then we have the E naught value. The magnitude of the electric field is 3 volts per meter. So now we have to find the magnitude of the magnetic field. So in our lecture, we learned that the ratio of the ratio of the electric field and the magnetic field is equal to the intrinsic impedance of the medium. So we can take the ratio of the electric field and the magnetic field and make it equal to the intrinsic impedance. So for a case where it is not a vacuum, you have to divide the intrinsic impedance by the epsilon r in order for us to we have to divide the intrinsic impedance that corresponds to the vacuum by the square root of the epsilon r, or permittivity of the medium, to obtain the intrinsic impedance of the medium. So the intrinsic impedance of the vacuum we can find using mu naught over epsilon naught. So if you can remember these values, you can substitute them into this, and you can find the value of the intrinsic impedance in vacuum. So you can find the values by substituting the given values. Also, like, it is easy for us to remember that the intrinsic impedance of a vacuum is 337 ohms, right? So you can use that, you can keep that in memory and use that as well. So you can get the value for this ratio using this equation, and then you can find the magnitude of the magnetic field by taking the ratio between the magnitude of the electric field divided by this 337 ohms divided by 2.8. So once you have a value for that, you can find the final value as maybe K naught. The units of the magnetic field is amperes per meter. So finally, you can write as the amplitude of the magnetic field is K naught amperes per meters. You have to find what K naught is and substitute, and then you can write the direction of the magnetic field is along x-axis, sorry, z-axis. So we have done the first question, first part. Then we have to find the wave velocity and the wavelength, right? Wave velocity, how do you find? So we have a certain equation to find the wave velocity, right? So we know that in a vacuum, the velocity of the electromagnetic wave is c, or the speed of light. So for a medium, the velocity of the wave would be c divided by the epsilon r square root. So you have to divide 3 into 10 to the 8 by 2.8 square root, and then you will be able to find a certain velocity in terms of meters per second. So the velocity of the wave is v naught ms minus 1. So the wavelength of the wave is you have to find that using our notation that